In a recent comment, JP Karenko6952 asked for a basic breakdown of how I tweak my engines. Sure, there's only one caveat. I don't use JMRI. It is entirely possible to program your engines and consist them quite easily just by using your NCE controller, a pen, paper, and some basic math. It helps that I am using Tsunami 2s in this particular case, which come equipped with excellent documentation. As with any manual, I would recommend reading it through. I visited the Soundtrack's website, and under their documentation page I grabbed and printed copies of their Tsunami 2 Diesel User Guide and Diesel Technical Guide. While the user guide is less technical than the technical guide doesn't explain certain features as well as the user guide. And since we're going tactile, I got myself a nice pen that's fun to write with and a respectable notebook, and that's pretty much everything I need for analog JMRI. That and some time and patience. I really can't stress enough the importance of taking good notes. There are a lot of numbers I will need to remember, and without taking notes, it is really easy to make mistakes. With good notes, I can quickly and easily go back and see where the engine is at and update it as necessary. Speed matching can be a painful experience, and you will want to take crying breaks in between tweaking. In this video, I'm going to cover the following topics: enabling custom speed tables, using motor control variables to reduce the engine speed, enabling automatic brake sounds, enabling dynamic digital exhaust, speed matching to engines, adjusting trim values as needed, configuring the engines using CV19, configuring functions with CV21, configure lights with CV22, and finally, set momentum. Before I start, I want to say that you should not try any of what I'm doing here. Just because you're watching this on the internet in what appears to be a legitimate YouTube video, it does not mean I'm an expert. I am not. If you decide to try and do this on any of your models, you are making the decision to take this risk. And as such, I will not be providing any technical support if things go wrong. I honestly don't know any more than what the manuals are telling me and forums are speculating. CV29 is one of those configuration CVs that handles a whole bunch of features. I know by experience that 50 is the number I want, which gives me the speed tables I am after, plus forward direction, 28/128 speed steps, and 4-digit local addresses, while disabling DC and Railcom. If you search for CV29 calculator, you can pick and choose what feature works best for you and use the number it generates as your CV29 value. With speed tables enabled, we now need to look at CV25, which allows me to configure user-defined speed tables. The default is 0, which leaves speed tables disabled, 2 gives you a linear speed table, and 16 gives you user-defined tables. I'm changing it to 16 so I can use CV67-294 to change the value of each step. You may as well change CV67 to 1, which is the lowest setting, while you're here. CV215 controls the back EMF reference voltage, which adjusts motor speed for consistent performance by responding to feedback. Although the documentation is unclear and forums are filled with incorrect theories, setting CV215 helps fine-tune how smoothly a locomotive runs, especially at low speeds. For switching layouts, lowering CV215 from 150 to 60 improves slow speed control, ideal for precise tasks like switching and shunting. How slow is too slow? That's up to you. Here is CV215 set to 150, and here is the moment I switch it to 60. Automatic brake sounds are neat, come gradually to a stop and the engine idles down. Quickly bring your speed to 0 and the engine comes to a grinding halt with squealing brakes with lots of air compressor noises. This is a 3-step process. First, set CV198 to a value of 4 to enable the auto brake feature. Then adjust brake sensitivity by giving CV196 a value of 100, effectively making the auto brake kick in when you drop 4 or more steps rapidly. And if you don't want to go deaf, I'd recommend changing the brake squeal volume using CV139. I like a value of 50. Despite the automatic brakes, I still like manually using brakes. On a Tsunami 2, the type of brake and brake selection is assigned to function keys 11 and 12, which I don't have on my controller. Since I don't use RPM plus and RPM minus, which are assigned to function 5 and 6, I'll swap these around. Page 56 of the Diesel user guide explains how this works. Set CV31 to a value of 16 to access CV index 1. Set CV32, which is CV index 2, to a value of 1 to access index CV page 1, giving you access to CVs 1.257 to 1.384. Boy, what a mess. Does this make any sense? Well, just follow along. Now you can map function 0 to function 28 by giving them the corresponding effect, the value we want. I made the following changes. Function F5 for RPM plus using CV285 was set to 11 or function 11. Function F6 for RPM minus using CV286 was set to 12 or function 12. Meanwhile, function 11 for the independent train brake using CV275 was set to 5 or F5. And function 12 for the brake select train line charge using CV283 was set to 6 or function 6. The manual recommends setting CV117 that handles the braking rate for independent brakes most often applied when running only a locomotive to 178 for a more rapid braking rate. I find the engine stop on a dime and a value 145 works for a smoother stop. By that same logic, train brake implies a heavier train, so you can set CV118 to a value of 100 for a more gradual braking rate. With this done, it is time to enable digital dynamic exhaust so you can have a more dynamic and organic engine sound. Digital dynamic exhaust configuration is, well, exhausting due to the sheer number of steps, but the automatic changes in engine winding are absolutely worth it. A breakdown of dynamic digital exhaust can be found on page 52 of the user guide, and it involves load offset, load slope, prime mover low volume limit, prime mover high volume limit, attack time constant, release time constant, throttle sensitivity, and load sensitivity. As noted, when it comes to dynamic digital exhaust, I will be using the Tsunami 2 Diesel user guide to the letter. For whatever reason, the process to enabling this feature is better explained here. In fact, many of the random sounds features are better explained here, albeit aside from maybe the clickety-clack, which I'm still torn about. Many of these sounds, such as door slams or how often our random engineer flushed the toilet, are pretty useless to me. To start, set CV31 for CV index 1 to a value of 16, then set CV32 to a value of 2 to access index CV page 2. This allows you to adjust DDE control CVs by accessing CVs 2.503 to 2.512 from your command station. The manual recommends running the engines for a few minutes as it will provide better results during the calibration procedures. Set your speed to 128 steps, set the throttle to speed step 1, and when your locomotive is on level track, enter a value of 255 into CV503 for the load offset to automatically calibrate the nominal low speed load level. Increase the throttle to an appropriate moderate speed for your layout, generally between speed step 25 and speed step 40. And when your locomotive is on level track, enter a value of 255 into CV504 for the load slope to automatically calibrate the nominal high speed load level. At this point, set CV512, the load sensitivity, to a value of 16, which is a good place to start. And note that a non-zero value is required for the effect to take place. Run the locomotive and observe the performance, and then adjust CV512 up or down to meet your preferences. For me, 16 worked just fine. However, I did raise it for some of the models to further break any chances of monotony. The manual notes that for best results, the auto notching should be set to 15 speed steps. This is explained on page 35. I just set CV114 to 15. Since the manual recommends changing auto notching at this step, CV114 can also be used to disable auto start. Otherwise, as soon as the layout powers on, all the engines come to life for quite the fanfare. Just by entering 15, you're automatically disabling engine interlock, auto start, and dynamic brake mode. I have no use for these features, but your mileage may vary. At this point, you have the option to adjust volume, time constants, and sensitivity levels. I'm usually pretty happy with the default time constant, so really up to you. You will, however, find with the right sensitivity level, you can get that organic engine feathering that gives the sound a more natural sound, rather than the repetitives found in other manufacturers. In my case, I set the following values. CV507 for prime mover low volume limit, the default is 0, but I opted for 100 on some models. Test it out and see what works for you. CV508, the default is 255, and well, you will enjoy giving your engines juice as they get very loud until idling out. CV509 and CV510, the default for 509 and 510 is 215, and I've left it as such. It really smooths things out and works perfect out of the box as too low or too high and things start to sound a little unnatural. Throttle sensitivity, another default which smooths things out at start, I've left it at 10. And of course CV512, your TDE load sensitivity, and 16 as the default. Works for most cases, but I've increased it to make engines rev up and down a little more often. DDE may have seemed like a lot of work, but at least it was pretty straightforward. You follow the instructions, tweak a few values to your liking, and you're done. Speed matching two engines on the other end is a bit of a game of trial and error, and as you increase the speed between the two engines, any disparity will become more obvious, forcing you to tweak numbers you thought were already correct. The problem here is that I can't really just give you a set of numbers. Each engine, even the same engine from the same manufacturer, don't all run the same way. One model may go up nicely in 1s and 2s, while the other is pulling numbers out of a hat to match. You're kind of on your own here. Yes, it is a painstaking task, but it is a possible task, and the results at the end is absolutely worth it. But before you think the hard part is done, there is more. I start by putting the engines side by side and running them together, picking one as the master and one as the slave. The master sets the tone and the slave is the engine that gets the tweaks to match the master as close as possible. I use the recall button to switch between them, then with the programming on main function I change the values from CV67 and working my way up all the way to CV94, trying to get the slave to match the master as close as possible. Yes, it's a lot of buttons, but I don't know a better way of doing this, at least not to the level of obsession that I operate at. As you move up the speed table, speed discrepancies between the two models will start to become more obvious. The goal here is to get them up the speed table working as closely as possible with as little arguing with each other. It's okay to cry, I know I have. Once you reach the end, whether speed step 28 or in my case speed step 13, run them side by side and start tweaking CV66 for the forward trim and CV95 for the reverse trim. And those numbers depend on which direction the engine is facing and which direction it is traveling. For added fun, if that's what you want to call it, it may be hard to tell of any disparity between the two models at low speed steps, but they will become more evident as you work your way up the speed table and adjust DCVs. As mentioned before, 66 adjusts the speed forward and 95 backwards. Run the engines back and forth with each other and watch the couplers closely. They will come close and push away a little as they travel, but you're looking for them to be about the same distance throughout the entire trip. If one lags behind, switch to the faster one, go into programming on the main, and start subtracting from 128 from CV66 if you're moving forward or 95 if you're moving backwards until you get close. Then speed up a little and do it all over again until you get to a point where you're comfortable enough that the two engines are traveling back and forth next to each other at equal speeds. And in case you're wondering, the values of 66 and 95 may not even match. They'll be close, but it is entirely possible they won't be the same even for the same model. As I may have noted, I only speed match up to speed step 13 as my layout is too little, so speed step 13 to 28 have the same value. What's interesting is that neither the momentum feature nor the engine sound see it that way. So as you keep raising the speed, the engine keeps traveling at the same speed, but the motor starts working harder, as if pulling a heavy load. And when you slam on the brakes by bringing the speed to 0, instead of the standard brake squeal, you'll get an engine revving down until it just coasts to a stop. Here, let me show you. I'm not sure if this was intentional or a side effect of the setup that I did, but the neat factor is pretty huge. Now that you lost sleep and your sanity over speed matching, it's time to make your two engines operate as one with consisting. Page 22 of the Technical Deezer Guide basically explains this. If you have engines facing away from each other, the one that goes forward can have a number between 1 and 127, which will be the number you will summon the consist with, while the one facing the opposite direction will need to be the number you set for the forward-facing engine plus 128. Confused yet? This engine has a CV19 set to 1, and when I hit forward, goes forward. The other engine faces backward. If I was to give this engine a CV19 of 1 and I hit forward, the two engines will go opposite directions. So I need to give this model a CV of 1 plus 128 for a total of 129. When I select engine 1 and hit forward, both engines will go to the same direction. CV21 allows you to pick and choose which functions from function 1 to function 8 you want the engines to have. For example, if you want to enable lights, horn, and bell on a model, you would add the values of bit 0 to bit 2 and put that into CV21. In this case, bit 0 is 1, bit 1 is 2, and bit 2 is 4 for a total of 7. I plan on using functions 1 through 8, so I'll give this a score of 255. You can see this under page 66 of the user guide for both models. Functions 8 silences both models, and function 5 and 6 are related to the switch brake settings I discussed earlier. Please refer to your model's manual to identify what functions your keys have. These engines don't have more than a headlight to worry about, so setting CV22 to a value of 1 ensures that whichever engine is going forward has their headlight on, and when going backwards, their rear lights stay off. At this point, you may want to tweak CV3 and CV4 for momentum to make sure it matches on both engines. Run the engines back and forth, speeding them up and slowing them down, and slowly decrease the values for one that goes too fast. You're basically doing a speed match all over again for matching for acceleration and deceleration. I like my trains moving slowly and feeling heavy, and will eventually pick a pretty high value, but I'll start with 50 and see how this works. CV3 and CV4 for starting and stopping respectively are set to the same number. This helps me in getting that slow start and slowly coming to a halt behavior I crave and test out the automatic brakes. CV112 to 0 to disable low pressure bell and all the other features, and also gain the feature that when the engines are not moving and you press the emergency stop button, the models perform their shutdown sequence. If you like using true idle, you can give CV112 a value of 4, which is what I'm using. After thoroughly configuring and tweaking multiple engines with a variety of decoder brands, I've realized that every DCC decoder has its own unique strengths and limitations. The key takeaway is that no decoder is perfect. Some provide great sound but limited customization, while others offer extensive flexibility but come with additional cost and complexities. This makes it difficult to find a single decoder that meets all needs seamlessly. In the end, choosing a decoder often involves compromise, picking the one whose drawbacks are the least disruptive to your specific use case. Personally, I prioritize organic sounds, realistic brake squeals, and the ability to customize my engine's behavior by adjusting the CVs. So the real question isn't about finding the best decoder, but rather finding the one that aligns most closely with your priorities. In other words, no decoder is a good decoder because each one comes with trade-offs that may not fully match your ideal setup. Ultimately, every model railroader must decide which features are essential and which ones they can live without. For me, using Tsunami 2 decoders, while not perfect, strike a workable balance giving me the feature I value the most. However, for others, a different decoder might offer a better fit. In the end, the perfect decoder is the one that gets you on the track with the least frustration, allowing you to enjoy what we all love most: running trains.